Today we are going to learn about Vogel's approximation method or VAM. What is Vogel's approximation method? Allocating in the minimum valued cell of a row or column which corresponds to the greatest penalty of the transportation table. Okay, so we are going to allocate the row or column which corresponds to the greatest penalty. What is the penalty? Difference between the smallest and second smallest elements of a row or column. Okay, so first of all we are going to find the penalty value. Using this penalty value we are going to identify a row or column of the transportation table to which we are going to make the allocation, and in that row or column we are going to identify the minimum valued cell. Okay, so that is called Vogel's approximation method. Okay, so here is our balanced transportation table. We have taken only the table. First of all we are going to find the penalty values of each row and column. Okay, so here for the first row, this is our first row. For the first row, which is the smaller element, the first smallest element is 2 and the next smallest element is 3. So the difference 3 minus 2 is 1. Okay, so this is our penalty for the first row. And for second row, 0 is the smallest element and 1 is the second smallest element. Here we have two smallest elements, 1. Okay, but anyways the difference between 1 and 0 is equal to 1. Okay, so the smallest element and the second smallest element, the difference is 1. So the penalty for second row is 1. And for the third row, the smallest element is 5, the second smallest element is 8 and the difference is 3. So the penalty for third row is 3. And for columns, for the first column, 1 is the smallest element, 2 is the second smallest element, their difference is 1. So that is the penalty for first column. And for second column, 0 is the minimum and 3 is the second minimum element, so their difference is 3. 3 is the penalty for second column. And likewise for the third column, smallest and second smallest elements are 6 and 11, their difference is 5. So this is the penalty for third column. And for fourth column, the minimum and next minimum are 1 and 7, their difference is 6. 7 minus 1, 6. So this is the penalty for fourth column. So in these penalty values we have to identify the greatest penalty. Okay, the greatest penalty. Which is the greatest penalty? We have to find out among the penalty values. Okay, so which is the greatest value? 6 is the greatest value. So here we have the penalty values 1, 3, 5, 6, 3, 1, 6. Here 6 is the maximum penalty, greatest penalty. So this column we are going to allocate. Okay, so this 6 corresponds to the fourth column. 6 is the penalty of fourth column, so that we are going to make the first allocation in the fourth column. Okay, in this column we are going to allocate minimum valued cell. Okay, so here which is the minimum value? 7, 1 and 9. 1 is the minimum, so here we are going to make allocation. Okay, so this step has been explained in the definition of VAM method. Okay, allocating in the minimum valued cell which corresponds to the row or column that has the maximum penalty, right? Greatest penalty or maximum penalty. Okay, so here fourth column corresponds to the maximum penalty, so that column, and in that column we have identified the minimum valued cell. Okay, so here we are going to make the first allocation. So that what is the allocation here? 1 is the supply value and 2 is the demand value. In these two numbers, 1 is the minimum, so we have allocated 1. And here from this 2 we have 1 balance, and here 1 is fully used, so this row has been eliminated. So this is our reduced matrix. For this matrix again we are going to find the penalty. Okay, for the first row, again 2 is the smallest element and 3 is the second smallest element, their difference is 1. So the penalty for row 1 equal to 1. And for second row, the minimum and next minimum are 5 and 8. Okay, so here the difference is 3, so the penalty is 3. and for the first column the minimum is 2 and the next minimum is 5. So here we have only 2 elements, so we are finding the difference of these 2 elements. Okay, the difference is 3, so the penalty is 3, and here 8 and 3 difference is 5, so the penalty is 5, and here 15 and 11, which is the difference 4, so their penalty is 4. For the fourth column the difference is 2, so the penalty value is 2. Among these penalty values we have to identify the maximum one. Okay, so here which is the maximum value? 5. So this 5 is the penalty of second column. Okay, this 5 is the penalty of second column. So for the second column we are going to make the allocation. In second column we have to allocate to the minimum valued cell. Okay, so here we have two cells, 8 and 3. Here which is the minimum one? 3 is the minimum value, so here we are going to make the allocation. Okay, so for this cell 5 is the demand value and 6 is the supply value, so we are allocating 5 here, and the whole units 5 has been used, so this column has been eliminated, and from this 6 units we have a balance of 1 unit. Okay, so our reduced table will be like this. For this table also we have to find the penalty values. For the first row, which is the minimum next minimum, 2 is the minimum and 7 is the next minimum. Their difference is 5, so 5 is the penalty for first row. And for second row, 5 is the first smallest element and 9 is the second smallest element. Their difference is 4, so 4 is the penalty for second row. And for the first column, 3 is the penalty, and for the second column 4 is the penalty, and for third column 2 is the penalty. Okay, so in these penalty values 5 is the maximum penalty. Okay, so this 5 is the penalty of first row. Okay, so we have to allocate for the first row. Okay, so we have chosen the first row. For this first row we have to identify the minimum valued cell. Okay, here 2 is the minimum valued cell, so this place we are going to make the allocation. Okay, for the cell 1 is the supply and 7 is the demand, so here minimum is 1, so we have allocated 1, and the balance is 6, and here there is no balance, so this row has been eliminated. Okay, so this is our reduced matrix. For this reduced matrix, here we have only one row, so there is no need to find out the difference between the values. Okay, so we can directly allocate according to the minimum cell and the next minimum cell. Okay, so here which is the minimum one? 5 is the minimum one, so here we are going to make the first allocation. Okay, so here for this cell 10 is the supply and 6 is the demand, so the minimum is 6, so we have allocated 6, and here the all units has been used, so that this column has been eliminated. Okay, from this 10 units we have used 6 units, so we have a balance of 4 units. Okay, for the remaining 2 cells, this is the remaining table, and here 9 is the minimum, so here we are going to allocate, and here 4 is the supply and 1 is the demand, so in these two numbers 1 is the minimum, so we are allocating 1, and there is no balance here, and from 4 units we have used 1 unit and a balance of 3 units we are having. Okay, and the remaining cell we have to allocate. The supply and the demand we are comparing, both are equal value, so we are allocating 3 units. So here both the demand and supply, all units has been used. Okay, there is no remaining value here, so that we are going to substitute our allocations into the original table. Okay, from the first step we have allocated 1 here, and from the second step we have made this allocation, and in the third step we have made this allocation, and in the fourth step we have made this allocation, and in the fifth step and the finally we have made allocation to this cell. Okay, so after making the allocation we have to verify the allocations row wise and column wise, and here for the first row 1 plus 5 equal to 6, and for the second row 1 equal to 1. For the third row 6 plus 3 9 plus 1 equal to 10 units. Okay, likewise for the columns 1 plus 6 equal to 7, 5 equal to 5, 3 units, and 1 plus 1 equal to 2 units. Okay, and our transfer allocations, and finding the transportation cost, we will get a cost of 102 rupees, which is smaller than the cost we have got from any other methods. Okay, so VAM method is the most optimal method. If you want to find the optimal solution, we will use and prefer to use the VAM method. Okay, thank you.